Okay, today we're talking about the second half of 1.6, which is decompositions. It's kind of like the difference between when you are asked to FOIL two binomials, when you multiply them together, compared to factoring it. One of them is putting them together, one of them is pulling them apart. Well, Friday we talked about the putting it together part of it, the composition, plugging one function into the other. Today we're talking about pulling two things apart. If I were to decompose a function, what two functions could have been put together to get that in the first place. There are several methods of how to do a decomposition, and the hard part about checking our answers is there's more than one correct answer. So as we look at like an answer key, what you'll see is sample answers, guesses at the most common ones that are out there, but it's not necessarily all of the correct answers. And the method I use runs through our parent function. So we kind of just looked at our parent functions as we did our warm-up and graphed those. But one of the things I want to take you back to is when we learned our parent functions. I took a slide that day and we put a big chart up there and we talked about what was considered inside and outside of our parent function, right? And for each of the individual ones, it's a little bit different. But if you consider what's inside of your parent function, doing a decomposition, a lot of times we can just take the insides out and call that what was put into our function. So for a fraction, we would look at the denominator and call the denominator the insides of our parent function. For a radical, whether it's a square root or a cube root, it's just what's inside of the radical symbol itself, along with our absolute value. Those ones are the easy ones to visually see because they're physically inside of a symbol. When we get down to exponents, remember these ones are the ones probably that are the hardest to see inside versus outside, and you're looking for parentheses. In order for me to consider something inside of an exponential, it would be inside of parentheses. So if it's not grouped with parentheses, it's not considered the insides of that function. If you can identify the insides of a function, and it is more than just the letter x, which all of these would be just the letter x, if we're able to say that it is more than just the letter x, that is an easy decomposition to just take out the insides of that function. So I don't have a lot of examples today. In fact, we have two. That is it. And so make sure that if you have questions that you're asking them. But this is what directions on this would look like. It says find two functions f and g such that h of x is the composition of those, f of g. And then they tell us what h of x is, 1 over x plus 2 quantity squared. They're saying that neither of your answers can be just the letter x when you're all said and done. So anytime we're doing a decomposition, that's just a general rule. Neither of your answers can just be x. Okay? So we're going to look at this in one of two ways. Let's examine that first function they give us, h of x equals 1 over x plus 2 quantity squared. And I would say that there are probably two parent functions that if I looked at these, two different parent functions jump out at me. What's one of the parent functions that kind of stands out as you look at this one? 1 over x? Yeah, 1 over x, absolutely. If I look at this as the parent function 1 over x, we talked about that the insides of 1 over x would be the denominator, right? So if I want to do a decomposition, I will let g be the insides of my parent function, okay? So g of x, for this example, if we look at it as 1 over x, the insides would be the denominator. So I would say that g of x is x plus 2 quantity squared. When I do that, whatever I identify as g of x, f of x is what's left over when I take that and make it the letter x. So if I take out g and replace it with the letter x, it would be 1 over x would be f of x, where I let x hold the place of everything I took out of the insides that we called g of x. Okay. If I were to then do the composition f of g, I would get back to that. You can, if you look at it as an exponent. So that was kind of the second one. So if I look at it as a fraction, the entire denominator is considered the insides of a fraction. So I let the entire denominator be g of x. And you're exactly right, because I think you could have looked at this instead as an exponent. And so instead, if we look at this as the parent function x squared, The insides would become what's inside our parentheses. And so that would be x plus 2. Then I would call the insides, or my g of x, x plus 2. And if I do that, f of x is 1 over, and then replace what I took out with an x, x squared. So that would be a second correct answer, or a second decomposition of that same exact problem, which again is why this one's a little bit harder to check answers or put an answer key up for, because there's more than one correct way to do this. Any questions on that? So look for the insides. Look for the insides, write that out as your g of x. Cross that off with a big old x, and that's what you're replacing that with when you write out f of x. There is one trick one that they will do to us, and that is when they hand us, so this is the same situation, when they hand us a polynomial to start with. If they give us a polynomial, it is not going to look like any of our parent functions to begin with. That's a polynomial, 3x squared minus 12x plus 12. Okay? If that's the trick that they do to us, I am going to start by factoring it. And I will tell you, I'm going to tell you right now that they will create this so that it'll work out nicely in the end. Okay? So let's look at factoring this one. First of all, h of x has a GCF, so I would pull that GCF out front, leaving me with x squared minus 4x plus 4. Factors here, factors of positive 4 that add up to negative 4 would be negative 2 and negative 2. Now, I told you that they were going to create it in a way that this was going to work out nicely for us. Notice that our two factors are identical, right? X minus 2 and x minus 2. And instead of writing them separately twice, I can write it one time squared. Yes, that's what squared means. That times itself. Okay. And now that I haven't done anything yet except for factored the polynomial they handed us, but now can you see one of our parent functions showing up there? Isn't this like an x squared? So I can look at this as my insides being x minus 2. And again, then writing my function f of x, if I were to replace that x minus 2 with an x, this would be 3x squared. Questions on that? The whole insides thing is not the only way to do this. I just find it the easiest way. And I just want to show you, we could have, again, done that a second way once we got to the factored part of it. I could take this out of here and call that my g of x. It's not the insides, which is why I didn't really jump to this, but if I do that again, I can replace that entire thing with the letter x and call f of x 3x. As long as those two answers are not plain x, it's okay. Sailor.
Is x squared counted as plain x?
Nope.
So why would it be x squared? Because like in the last problem,
Here?
Yeah, it was the parent function that was f of x. So why wouldn't it just be x squared?
We have to get the 3 in there somehow, because when I do my composition, I have to get back to this guy. So it's not always going to be just the plain parent function. I don't know if we could do a decomposition where it would just be plain x squared. Yeah, so we look for those parent functions to kind of guide us through the inside-outside things, but if there is like a vertical stretch or something, that's still going to be on the outside of that function. Okay. Other questions? All right. The last one is just for a discussion at your table. I've got h of x in the middle here. It is the square root of x minus 1 over 3. They picked a way to decompose it. It is not the way we probably would have attacked it, but it's multiple choice, so we have to go with their options. One of those is a correct decomposition of h of x. So take a second and look through that and see if you can narrow it down to a correct decomposition of that. Okay, I'll give you some time to talk at your tables. Okay, sometimes, first of all, sometimes the multiple choice does not go the way that we want it to. If I were attacking this problem the way I had showed you to, I probably would have taken out the insides of the radical and called g of x, x minus 1, and then I would have called f of x. Replace that with the letter x, so square root of x over 3. That's another option. That's not an option that's listed over here, right? So again, it goes back to the whole decomposition thing. There are several options. But sometimes it's hard to just look at this and see our decomposition, so maybe I go the other way. One of these, when I do the composition f of g, gives me that answer, and maybe that's the route we take. So if I go that route, remember a composition, if I'm plugging g into f, wherever there is an x in f, I'm supposed to plug that function in. Okay, so I would write out f, and wherever there was an x, I put in x over 3. Okay, well, does that match that? No. Okay, so it's not A, right? And I could keep doing that method. Wherever there's an x, I replace it with this. So that would be 3 over square root of x minus 1. That's not the same thing, is it? Do the same thing. Wherever there's an x, I replace it with the square root of x minus 1. Okay, that is the one that matches. Should have gotten this down to option C. Questions on that? Okay. Your assignment is kind of a little bit of both. We've got some more practice of the other type of compositions, but we do have some decompositions in there. You are on page 61. You guys have a ton of work time today. Probably walking out of here with your assignment done, but also I need you to be listening for your name because I'm going to call you back and we're going to go through your parent function.